All right, let's take a look at this. This should be fairly easy. I'm going to show you how to do it. It's important that you listen because we're gonna do this in my head. Like, you don't have to write so much down. So it says graph y equals, well, maybe I'll change it. I'll change it. That means the same thing. Graph q of x equals negative 1 over 3 x squared plus 2. So again, make a table. So what we're going to do is have x, yeah, I'll put negative 2, negative 1, 0, 1, and 2. Put that in my table for the x's. In the y's, well, I'll just do what this is. I'll do what that says there. So first, I need to square my x value. So I have the negative 1/3. I'm only going to write it down for this. And then the x squared, that's just the same thing as parentheses squared with the negative 2 in there. This would be over 1. And then at the end I have to add 2. So what is this? This is, well, that first is 4. Negative 2 times negative 2 is 4. So this is negative 1 over 3 times positive 4 over 1. Plus 2, which is negative 4, right? I multiply straight across the top. Negative 4 and positive 3 plus 2. And then I'll write this as a decimal. This is negative 1.3 repeating plus 2, which is positive 0.6 repeating. So there we go. My x value is negative 2. That seems like a lot of work, but you can just do it all in your calculator. It's so easy. So almost half. And then here, if I plug in a negative 1, well, negative 1 squared is 1. 1 times negative 1 is negative 1. And then divided by the 3, that would just be 0.3, right? Negative 0.3, repeating. So my y value ends up being positive 1.6, repeating. If I plug in 0, I get 0 squared times this, times the 1, that would be just 0 over 3, which is 0, plus 2 is 2. And then this is 1.6. It's got to be the same, repeating. And this one is going to be the same as this. So it's just 0.6 repeating. So it's just to graph it and make a table of values. And you don't have to write down all of that. You could just do that in your calculator. That's got to be the easiest part. That's got to be something that you can do. So hopefully you paid attention when we did that. And there you go. So let's graph this thing. Well, I know I have a negative a value, so this should open downwards. So if I don't get opening downwards, that's a problem. First, I graph negative 2, negative 2.6. The highest I go is 2, so I'll 1, 2, 1, 2, 1, 2, 1, 2. So negative 2, that corresponds to 1, 2, and then 0.6 is right there. So I graph that just in the middle, a little bit above the middle, actually. So there's that. And then, negative 1 and 1.6. Well, that's negative 1 up 1.6. So somewhere around here. And then I have 0 and 2, so I don't move at all. And then I go up 2. And then continue on. This is easy. 1.6, somewhere right around there. And 2.6, somewhere right around there. So it looks like this. Cool. That's pretty simple. Now the title of these videos were graphing y equals ax squared plus c and zeros of a function. So let's talk about what zeros are. Zeros are simply where the graph crosses the x-axis. That's it. That's it. There and there. Those are the zeros. And I'll show you how to solve for them algebraically, without graphing, in a little bit. That's the easy way. So zeros, those are simply where the graph crosses the x-axis. So they also have other names for it, just for fun, to confuse you. I think, probably. But they're also called roots or solutions. Solutions, call them x-intercepts as well. So that's what we have here. So the zeros of a graph, or sorry, the zeros of a function, are where the graph crosses the x-axis, and it's the same thing as roots, solutions, or x-intercepts. Those are the different names for them. Let's do an algebraic example, how to find the zeros. So, find the zeros of the function. Here's the thing. It's nice that they call them zeros because watch this. The x coordinate here, I don't know, maybe looks like 2.3 maybe. That's a guess. And then the y coordinate is always 0. Same with this. This would be like negative 2.3, and the y-coordinate would be 0. That's why they're called zeros. One of the reasons why they're called zeros. So if it says find the zeros of this, the first thing we do is make y 0. What's y? Well, the f of x. That's the same thing as y. So that's the first step. So that's what I'll do. I'll take this, which is f of x, the same thing as y. I will take that, I will make that 0, and everything else I will have equals to 3x squared minus 27. And now I'm trying to solve for x. So we have an x squared here, so we're going to have to get the x squared by itself. And we do that very easily by first getting the number over to the other side. We have to do the opposite. Since this is subtraction, we have to add 27 to both sides. So I will copy 27 equals 3x squared. That cancels out. Then, remember, you always have to divide by the number that's next to the x. So divide by 3. So that cancels to 1, and I just get x squared equals 9. And then here's something that's new. When you have x squared by itself, you take the square root of both sides. So you take the square root of both sides. So I'll do that here. Now, anytime you take the square root, you're going to have to put in a plus or minus. So x equals plus or minus. Square root of 9 is 3. Here's why. If I were to put in a negative 3 right here, well, negative 3 times itself gives you 9. So that it would also work, right? Maybe I'll put a step in between. So if I put in a negative 3 right here, negative 3 times negative 3 will give me 9. So that works. But if I put in a positive 3 also, positive 3 times positive 3 is also 9. So that's why we have to put the plus or minus. Anytime you do a square root, you have to put in a plus or minus. I know people are going to forget that. But that's the x-coordinate, and we know, just from up here, that the y-coordinates are going to be 0. So the zeros of the function are plus and minus 3. The x-intercepts, I would just say we have 3, 0, and negative 3, 0. So that's what I would say. Because my x is positive 3 and negative 3. So there we go. That's nice. How did I know to put a 0 in for the y-coordinate? Well, it says the first step is to make y 0. So we did that at the very beginning. I'm going to do another example in another video. Goodbye.